Hey, what's up? It's Randy. If I gave you this exponential equation right here, and I said find the value of t, a lot of you would probably be like, I don't even know where to start. But thanks to logarithms, you're going to find out how to solve an equation like this today. Let's do it. So we are told to solve the following equation for t. Notice that t is in the exponent right here. And we need to express our answer in two different ways. First of all, in logarithmic form. And then after we find logarithmic form, we'll need to express this as a decimal rounded to the nearest thousandth. And I chose to give us our old guide that we learned a few lessons ago that shows us the relationship between an exponential equation and a logarithmic equation, and this will definitely come in handy. All right, so we have 7 times 10 to the power of 9t equals 18. And when I see an equation like this, I think about, okay, I want to get at least 9t alone, and then eventually I want to get t alone. How could I do that? Well, let's look over at our guide. Notice that this exponent right here all of a sudden moves into the right side of the equation after we convert it into logarithmic form. So at first glance, if we can make this entire equation at least look like this, then we'll be able to try to convert it into a logarithmic equation, and then we'll probably be pretty close to finding the value of t. So let's try that. So in order for this equation to look like this one, we need to have a single base with an exponent on the left. But right now we have a base with an exponent, and it's also being multiplied by 7. So let's get rid of this 7 right here. How do we do that? We're going to divide both sides by 7, and then we'll go from there. All right, just like that. So on the left, the 7s cancel, and on the right, we're going to have 18 over 7. All right, look at that. Now we have the form that we're looking for, because 10 corresponds to b, 9t corresponds to x, and 18 over 7 corresponds to that y. So what do we do now? Let's convert all of this into a logarithm, and then we're going to have 9t alone on the right. So obviously we start with log, and then it's going to be log base what? Okay, well this right here is log base b. What was our b? 10 was b, right? So it's going to be log base 10. And although it's implied, for now I'll leave it there just as a reminder. All right, log base b of y. What was our y in this equation right here? The y is what is on the right, which is 18 over 7. So we're going to have log base 10 of 18 over 7. And then we have equals what? What was on the right side? X. All right, what was x in this equation right here? X was the exponent, right? So 9t goes on the right. 9t. All right, look at that. We're super close. Now we just want to get t alone. So let's divide both sides by 9. Divide by 9 and divide by 9. On the right side, the 9's cancel, and we're left just with t. And on the left, we have this entire big fraction. All right, so there's our first answer. They said, express your answer in both logarithmic form. Is this in logarithmic form? Yes, it is. And we have t isolated, so that is our first answer. And as we've discussed in a previous lesson, you could also just write this part as log or LG. So it could look like that, just log, or like that, LG. All right, now to get our decimal, let's just put all of that in the calculator and then round it to the nearest thousandth. So if you want to be, adventurous and just put it all in the calculator in one fell swoop, this is how it would look. And what do you get when you press equals? So we get approximately 0.04557. And just in case it's not already super clear, when we put a log in the calculator, when we click that button, the calculator is assuming that we're putting in log base 10. That's how the calculator understands it when we click the log button. All right, now let's do our rounding. Right here is the thousandths place. So what is the number after the thousandth place? It is a 5, which means that this number in the thousandths place, that's difficult to say, thousandths place, goes up to a 6 because of this 5 making it go up. All right, there it is. We now have expressed t in logarithmic form and as a decimal, rounding to the nearest thousandth. Okay, now before we go to the next example, let's do a little bit of a hypothetical on this one. What if instead of a 10 right here, we had e? What would we do there? Well, our process would be just about the same. We would still divide both sides by 7, and we would get this equation. And then we would use that same method that we used before to convert it into logarithmic form. And here's the logarithmic form we would get. And then if you want, instead of writing log base e, we learned recently that you can write ln instead of log base e. So in that case, your value in logarithmic form for t would be the natural log of 18 over 7, all divided by 9. Sometimes you'll even see the L written in cursive like that so that it's not confused with like a 1 or something. Same thing. All right, now what would we do to get the decimal value for this whole expression? Well, it'd be the same exact thing as before, but instead of using the log button in that place, you're going to use the ln button and then press equals. And then your rounded decimal would be 0.105. Okay, enough hypotheticals. Let's go to a problem now, this one, where we don't have the convenience of e or 10 in our base. Same instructions, so let's try to make this equation right here look like this exponential equation, and then we'll be able to convert it to a log. So first of all, divide both sides by 18. So the 18 on the left disappears, and we just have 8 to the power of 3t. And then let's replace 9 over 18 with 1/2. And look at that. Now we have 8 as b, 3t as x, and 1/2 as y. So we can convert it into a logarithmic equation. All right, there it is. We have log base b of our y is equal to x, which was 3t. All right, now let's get this t alone by dividing both sides by this 3. So on the right side, these 3's cancel, and we're left with just t. And right there is our first answer. Log base 8 of 1/2, all divided by 3, is the logarithmic form for the value of t, because we now have t alone. All right, last part, let's convert all of that to a decimal. But if you try to put log base 8 into your calculator, you can't. You need to use the change of base rule to convert that entire numerator into a fraction. So now we have log base 10 of the argument from this log divided by log base 8, which was from the base of that logarithm. Let's change this 1/2 to 0.5 to make our life a little bit easier as we put it in the calculator. So I'd say let's put the entire numerator in our calculator, just like I wrote here, and then we'll press equals and then click divide by 3. And we might as well have equals signs here instead of arrows because all of these expressions are equivalent. So after you put this entire numerator in your calculator and press equals, you should get negative 0.3 repeated. All right, now with that repeating decimal still in your calculator, just immediately click divide by 3, and what do you get? You get negative 0.1 repeated. So rounded to the nearest thousandths is negative 0.111. All right, so here is the first answer that they were asking for, logarithmic form, and here is the second one in the form of a decimal, rounded to the nearest thousandth. All right, so in a nutshell, how do we solve these types of equations when we have the variable in the exponent? First thing we do is convert the equation that they gave us into the exponential form that we're used to, and then we convert that exponential form into logarithmic form, and then lastly, you isolate the variable. All right, that is everything. See you next time.